0 to L equals 0. So we have these conditions, and with those conditions holding, what we have is this quantity right here. We have a dt on the outside here. It has to be equal to 0. And because this is, again, an arbitrary displacement, those are my epsilons, we can pop this outside of the integral, and we get an equation of motion, rho a partial squared u partial t squared is equal to partial with respect to x of ea partial u partial x. So in other words, you cannot just take Lagrange's equations and substitute in this kinetic and potential energy and get an equation of motion, but you can use variational calculus, which is very closely related to Lagrange's equations, to generate a partial differential equation which describes the motion of waves in this rock. Okay? And this kind of partial differential equation, when E times A is a constant, and when A times A is a constant, has a relatively simple solution. It's called the wave equation. So this is called the wave equation. And we're not going to focus on solving the wave equation. Most of this class is about generating the equations that describe motion rather than solving them. But there are, if you take a class on partial differential equations, it's all about solving the heat equation, the wave equation, etc. So the point that I want to get across with this example is simply that if you can write down a kinetic and potential energy for a continuous system, then you can also write an equation of motion for that continuous system, but it will be a partial differential equation as opposed to a system of ordinary differential equations. Like most of what we talk about in this class are systems of ordinary differential equations. Okay? Any questions about that? Because there's going to be a homework where you're going to derive a similar equation, not for a rod, but for a beam, which has a potential energy that looks like, well, you'll see when I give it to you. Okay? But the procedure will be essentially the same, and these notes will be posted so that you can follow them. But since we're out of time, I will send the email out by, I'll send the homework out by email, and which we'll be doing a week as well. Okay, I'll see you on Tuesday.
No, you won't. It's Monday.
No class on Tuesday. Is that right? Okay, so I'll see you on Thursday. We should probably have a midterm at some point. Well, we'll postpone it a little while. But, okay, so I'll see you on Thursday. Active or passive, just like you want it to just viscously sort of return? So do you have a spring in there also?
Yeah, like I haven't put a drill hole in it. So we're getting
yeah, I mean a combination of spring and damper would be good. I'll have to think about it a little bit. I mean, I don't have first-hand experience, but something may come to mind after I think about it.
Do you know anybody?
Better, nobody better that comes to mind, but you know, any of us who work in design, robotics, etc., would be equally good for that. But I can think about it a little bit.
Okay.
Okay.
Thank you.
Do we submit the homework on Blackboard?
That's usually, but if you want to give it to me, if that's your homework.
Yeah, it's just that we didn't see the link.
No submission.
Yeah.
Most people have been submitting. You mean for this particular one or in general?
Yeah, for this one.
Yeah. Well, email is good also. Let me ask Kendall. He can probably just set it up. Do you prefer to submit it by Blackboard? Well, I think Blackboard is the easiest. But if there's a problem, then you can scan it and email it, would be fine. Or if you wanted to give it to me now, it's okay. How do you feel about it? Well, you have access to a scanner and everything as a backup, then I think that's doing it electronically is the best, because then there's less chance of it to be misplaced.
All right.
So first thing, we'll ask Kendall about Blackboard, and then if Blackboard is not set up, just email a scanned version of it. Yeah, that's fine. Okay?
Thanks.
Sure.